it, delete it. Now the compiler's already kicked in. It's already compiling my pre-compiled headers and my header files from my source file, and it's ready to go. When I press fix, it's going to finish up the compile, it's going to link, it's going to build, and it's going to change my code. Now you might say that's cheating. I just changed 1 to a 4. I mean, I could do that with peek and poke, okay? No, this is really recompiling the object and using Mach-O and DYLD to dynamically link in the object to the running application. So I can change this constant to a function call, click fix, and it does the same thing. There we go. So where it really matters, where the rubber meets the road, in the compile, link, debug, step through, find a fix, fix it, and get back to work debugging your application, Xcode really makes your turnaround time incredibly faster. It's the best thing we've ever done in developer tools. There's going to be a whole couple hours on it at 3:30 this afternoon in the same room. Hope to see you there. Thank you very much.
Woo. Thank you, Chris. So, faster compiler, GCC 3.0, distributed compiling, zero link, predictive compiling, fix and continue in an entirely new user interface. This is Xcode. It is included in Mac OS X Panther. There is one more thing we wanted to talk about today. Now, some of you may have noticed on the net this. For those of you that have not been aware, there was a funny thing that happened on our website last Thursday, as I recall, where some specifications were posted on a PowerMac G4 page. It looked pretty remarkable. Now, the reaction to these specifications fell into one of three camps. One, it's too good to be true, can't be true. Nothing could ever be this good. Number two, it's true. And number three, it's brilliant marketing on Apple's part. We internally, one of the folks internally had a great name for this. He called it premature specification. But I am here today to tell you that it was a mistake, and it's true. But it doesn't even begin to tell the story that we get to tell you right here and now. We are delivering today the world's fastest personal computer. It's amazing. Now, there's three things. There's the chip, there's the system, and there's the product. And we're calling it the G5. Now, the G5 has some amazing properties. Number one, it is a 64-bit processor. It is the world's first 64-bit desktop processor. And it runs our existing 32-bit applications natively, no problems at all. 64-bit processor. Secondly, it is running at up to 2 gigahertz. This is the fastest 64-bit processor ever. Third, it has a 1 gigahertz front-side bus. It is the fastest front-side bus ever. And it is built for full symmetric multiprocessing. This thing has been designed from the ground up for dual processor systems. So, these are some of the highlights of the new G5. Now, it's got an entirely new architecture that has the industry's highest bandwidth. And let's just go through it for just a minute. First of all, it's massively parallel. It's got a 12-unit core. And what that means is we can have up to 215 in-flight instructions. Over 215 instructions can be being processed at the same time. The G4 can do 16. which means if your app can get this thing flying, it can scream. It's got an optimized velocity engine with a dual pipeline design. It's got 2 double precision floating point units. That's twice the G4. This thing is a floating point monster, as you will see. 2 fully symmetric integer units, that's twice the G4. 2 load and store units, twice the G4. And massive branch prediction logic, which I don't know what it does, predicts branches. I don't know. But it's a good thing. So, this is a new generation architecture, and this is just the beginning. And IBM has done a phenomenal job on this. We've worked with them very closely. And they also happen to have the world's most advanced chip fabrication on the planet. 130 nanometer process this is built in, silicon on insulator, 8-layer copper interconnects, 58 million transistors. I don't know how they count them. This thing is built on 300 millimeter wafers. These are 12-inch wafers. I happen to have one right now. This is how they build G5s. It's amazing. It's just amazing. And they build it in a $3 billion state-of-the-art semiconductor fabrication facility in Fishkill, New York, built in the USA. Now, this is what it's like. This is a city down there. It's amazing. And this is the map of the city. This is the processor itself, and this is how they're made. And they're made on these giant 12-inch wafers, untouched by human hands, in the most advanced semiconductor factory in the world, where robots move the wafers around. There are no people getting anywhere near these wafers. This is what it's like. It's a giant factory making these giant wafers. And we are thrilled with this partnership with IBM. It's producing dramatic results that we're announcing here today. And it's my pleasure to bring up Dr. John E. Kelly III. John's the Senior Vice President of all the technology groups at IBM. John, I'd like to welcome you here.
Thank you. Thanks, Steve. Thank you, Steve. What a great day for Apple, for IBM, for our Apple developers and Apple customers. So you're probably thinking, how did we do this? How did we catch up, and how do we pass our competition in one giant step? Well, what we did is we went to IBM and we took the DNA, the core, out of our highest performance 64-bit microprocessor supercomputers and brought it down into the 64-bit desktop processor, operating at 2 gigahertz, with a bus, as we showed, at 1 gigahertz. And the technology, we took our most advanced 130 nanometer technology, which, by the way, has a gate length, if you're a real geek like me, of under 50 nanometers. Horizontally, we shrunk to 13 angstroms, 6 to 7 atomic layers in the gate. This is very advanced technology. And that's why, by the way, I tell my boss it costs $3 billion for one of these fabs. Only IBM, in partnership with Apple, can produce this kind of technology, and I'm very proud of our teams and all that we've done. But team, this is just the beginning. As you know, IBM spends nearly $5 billion per year on R&D, in addition to big fabs like this. And much of that spending is aimed at our advanced microprocessor and semiconductor technology. And as we sit here today and as we speak, there are hundreds of IBM scientists and engineers working on the next generation. So we have a roadmap that's going to knock your socks off. And what a great partnership we have with Apple. Steve